So Chilin, she's also an IEEE leader, as kind of, you can say, co-founder of Open RAN activities, also in ORAN Alliance. She will be giving a talk, and you might have heard from her before. But in short, she's an IEEE fellow and a new leader, a great leader, a founding leader for Open RAN Alliance, and how this is paving the way for 6E. So with that, I'd like to welcome our keynote speaker, Chilin. Chilin, you have about 20 to 25 minutes to give your talk. Why don't you share your slides down?
Okay, I'm doing that right now. So can you see my slides now?
Should be coming up. Yeah, it's up. Thank you.
Okay. Oh, let me do the display mode.
Yeah, just put it in full mode, yeah.
I am trying to do it.
So I'll give you a 5-minute warning when time is about to come. Thanks.
Okay, I appreciate that. I cannot get this thing out of my way. Okay, so I'm starting with the title, which is kind of where we are right now and a kind of a priority, I think, for our whole overall ecosystem, gap analysis and alignment for 6G. Next page. So it will be two parts. The first part I will fly through very fast because I assume that most of participants are pretty familiar with a lot of the information there, but just in case there is some update. And then the second part is going to be the main body of the presentation. Okay. So the latest, from the beginning, I think all of the participants who are interested in Open RAN are very much familiar with the fact that from day one, when we established it with the 5 founding members, our mission was to develop the ICT deeper conversion technology, particularly for RAN, and making it open, smarter, and also virtual technologies, virtualization, container, VM, etc., and ensuring multi-vendor interoperability with our solution. And we are very blessed and lucky so far. We and over 300 participation encompassing the largest operators in the world jointly, 5.5 billion subscribers. And then in addition,
excuse me, Chilin, your audio is a little intermittent, so maybe you can speak closer to the microphone. Just
okay. Is it better this way? If I
just keep it close to thanks.
Okay. So we have a very diverse, I think, comprehensive composition of various ecosystem segments. I have listed here. I'm not going through. Basically, technology providers, operators, research academic institutes, and these days we also have strong interest and also participation from various interested regional government agencies as well. And our main 3 thrusts of our deliverables are, of course, the ORAN technical specs and also our testing, integration, certification effort, as well as our paired simultaneous development the ORAN software community, providing the open source prototype of our spec, our solutions. And you are probably also aware that we have grown into a really very active technical community with 11 working groups, 5 focus groups, 2 subcommittees, as well as a research group and open source community within the technical steering body of ORAN Alliance. And the baseline architecture from almost day one looks like this, and you are probably familiar, and especially some of the key enabling interfaces, A1, O1, O2, and E2, Y1, R1, etc., are all very key to enable the key capabilities that O-RAN solutions for the RAN is bringing value to our community. And a very brief summary so far, actually our members have joined and delivered, I think, over 650, close to 700 technical documents already. The great productivity and agility is really very impressive in my mind. And among those, there are exactly so far 118 unique titled technical specs, because some of those were older versions of the same title. But the unique titled current version, we have 118 of them. As of our March delivery, which means that they are at this point publicly available, it's published. But we actually have a new batch of delivery in July, which bring in another, I think, 60 plus technical documents, including 6 new unique titles as well. But it's not included in this number. And in terms of testing specification, you're probably aware that we cover conformance, interoperability, as well as end-to-end functional testing. But we are also building on some of the minimum viable feature package-based, not only function, but also performance testing badging. It's under development. And then so far, there are globally, we have approved 19 open testing integration centers, and jointly they have already awarded 23 certificates and badges to various ecosystem players. And our open source community has already released, as of July this year, 10 releases. And currently the 11th release, which is the K release, that's undergoing the development. And also our open source community has set up 3 open labs globally, 2 in North America, 1 in Asia Pacific area. And our annual Global Plug Fest has evolved into biannual, meaning that we have 2 Global Plug Fest events per year. And so far already completed 9 of them, and the 10th one is currently ongoing. And in addition, our technical spec has started being adopted by various regional standards bodies, starting with ETSI in September 2022. The first spec in our open front hall was adopted by ETSI, and currently there are 10 more O-RAN specs that has been adopted by ETSI. And then quite a few are under adoption process right now. And we have always had a very active and extensive collaboration, interaction, and partnership with various standards bodies and industry bodies, alliance. Some examples are listed here, including GSMA, ORIA, NGMN, SCF, OAI, BBF, IOWN. I think I should put in IEEE program as well. So I should excuse the absence of that. We'll add it in after this. Before I give you the copy for records. And this agreement and cooperation has covered a broad scope of the technologies, okay, including security, open source, test, integration, all of that. And the latest development is that the ETIS, which is the standard body in North America, and also TTA, the standard body in South Korea, are officially adopting, and actually adopting is a weaker word in this case, directly transposing O-RAN specs as their spec. This has been officially agreed. And then a little highlight of the latest available new titles of our technical specs. The March delivery, which is available already, publicly available, includes, it's highlighted and listed here, including the O-Cloud's energy saving and O-Cloud's information model, and the O-RAN topology exposure inventory, common information model and interfaces, plus the security for front haul, CAS plan, security for AI/ML, and the circular economy guidelines, as well as the zero trust architecture white paper. these are the unique titles that are publicly available, most recent sets. And then there are upcoming sets of new ones that will be available probably, I think, after 60 days. 60 days from now, because they are going through the final IPR check, internal check. But this will include the communication, computing, integrated networks, R1 interface test, and conflict mitigation of our control loops, and the O1 performance measurement, and the network source resource model, as well as further study on zero trust architecture. Okay, and then a few words about our very popular global Plug Fest. And the first one was held end of the 2019, and now it has evolved into biennial. And then also we finished the 9th one spring this year, which is the first one for this year. And but it was also special in the sense that it's the first ever Plug Fest with identified themes. And in this case, 6 themes were identified, including energy efficiency and consistent and repeatable testing across multiple OTICs or testing center. And then also the OFH, open front haul transport testing, and then layer 1 acceleration, as well as the end-to-end deployment templates, DevOps, and the test automation, etc. So these themes actually are going to be reused again for the second Global Plug Fest this year, which is actually, if you see the table on the right side, my right side, maybe your left side on the screen, you will see that we have passed the deadline for the call for participation, but it's a soft deadline. So if you are interested, you can still sign up to join. You will see that in our spring one, the one that was finished, we had 10 labs globally and 86 unique companies participating in the Spring Plug Fest. In general, we have much larger number participation in the fall version of the Plug Fest. So we expect that it will be the same this year. And then the actual Plug Fest activity is going to be held over a 12 weeks, almost 3 months period. So it has already started 2 days ago. It will go on until November 8th, okay? So again, like I said, that we still welcome additional participants if you are interested to join. The green deadline there can be considered a soft one. Okay. And I already mentioned earlier the 19 approved OTICs to provide a vendor-independent, open, and a fair environment for our ecosystem players to come and test their latest software, hardware, or any subset of the ORAN solutions. You'll see that actually right now we have 6 in Asia Pacific region, and 4 in Europe, and then a total of 9 OTICs just in North American area. And then our open source community effort actually was established, I think, officially in April 2019 jointly. This is a joint effort with Linux Foundation. And initially we accommodated 2 types of licenses. One is the common Linux Foundation's Apache 2.0 license. The second one is the more common friend type of ORAN software license that our traditional wireless industry are familiar with or comfortable with. And then gradually, by demand, we have increased and added 2 more type of licenses. One is specifically addressing the software copyright aspect, and the fourth one, the latest one, is actually another friend type of license regime, which is slightly different from the original ORAN friend. It's closer to the OAI friend. For people who are familiar with the OAI open source codes, you probably know what referring to. And then really from day one, our purpose, our intention to have this open source community is to, first of all, to provide a fast software prototyping vehicle for the technology that is developed out of our technical specs. But secondly, with the experience, we found out that there is actually a reverse order value in the relationship between our working groups that's developing technical spec and the open source code, in the sense that sometimes the software develop can go much faster because it's a lot agile. And so based on that experience, actually can provide feedback to accelerate or enhance our working group's work. We have a couple prominent examples, such as the non-real-time rig software project actually provided a very good input on A1 in terms of A1 interfaces for working group 2. And then in the same way that the INF software project made good contributions related to O2 to a working group 6. And I believe there is also ongoing interaction between our near real-time rig co-development project with working group 3 regarding the E2 interface as well. Okay, so far I already said we had 3 open labs globally that provide a platform for our open source community participants to try out their new development, and also to integrate with maybe other open source communities code, whether it is complementary or it is alternative. In this case, particularly the cooperation with OAI, Nephew, and Syria are examples to highlight in terms of this type of cross open source community collaboration. And then our open labs are also working on the interconnection among the 3 open labs, as well as interconnection of the 3 open labs with other large platforms, such as I think the ongoing ones, including Powder, maybe Cosmos, and also maybe expanding to Colosseum as well. And this is a little bit along the idea of I think the Federation of Testbed, or Federation of the Platform, that I think IEEE as well as ITU has been promoting. And then for 6G, we had to set up or kick off the research group NGRG about 2 years ago. And so far, there are 5 major research streams ongoing, covering use case, architecture, AI, security, and also research platform. And current status, very quickly, we have a technical oversight committee with 6 operators, 2 from each region, that is Asian Pacific, Europe, and North America. And then 6 vendors, 2 from each sector of the industry, meaning from CT, IT, and DT, 3 sectors. And then 3 academic thought leaders, 1 from each of the region, and then plus 1 hyperscaler. But we feel that it would be very valuable and helpful for us to expand our academic advisory committee. So we are, in addition to the existing 3 academic thought leaders, we are actively engaging additional academic leaders and active participants to join our advisory committee. So I know that this marvelous event that Ashutosh put together not only have major industry leaders participation, but also a lot of academic experts and the leaders as well. So if you're interested, please let us know. And then so far, jointly, the research group have delivered and published 13 research reports, which are available in our website, covering the topic that you can see I highlighted here, including cloud-friendly architecture or native AI or cross-domain AI, etc., as well as the security and testing and quality assurance, green technology, indoor digital twin, etc. These are already published, but there are quite a lot more that is ongoing and will be slowly coming. And also one special, I think, very prominent, I think, accomplishment is that even though the research group has only been established a little bit longer than 2 years, I think it was June 2022 officially launched this research group. We have so far successfully held 3 workshops per year, so 6 workshops has been held total, and each with a special theme. The first one was focusing on academic view about 6G. Second one was a regional view of 6G. And third one was vertical industries view. And then fourth one is on AI. The fifth one is on architecture. And finally, the latest one that we just held in June is on road to 6G standards. And also the group maintains active interaction, collaboration with many important organizations. Okay, we do have...
Jillian, you have 5 minutes.
Oh, sorry. We do have IEEE Future Networks here. Sorry.
Yeah, you have
oh my God.
Thanks.
My second part only have 5 minutes.
You have 5 minutes, yeah.
It's terrible.
Thanks.
This should have been the major part. Okay, so let me say it quickly, okay? As you probably know that our alliance is based on architecture started from the 3GPP 5G RAN specs. And we delivered a lot of complementary capabilities based on that baseline architecture. And we also know that there will be a upcoming workshop in March next year as the 3GPP's 6G study effort in release 20 will be kicked off. And thirdly, open intelligence codification, these are key features of O-RAN, and I think generally expected to be essential component in 6G enabling technologies. So our goal is to, first, of course, the high-level goal is to ensure globally unified 6G standards, avoid ecosystem fragmentation. And particularly, well, we think that the most challenging area may be consistency between O-RAN, 3GPP, particularly in the intelligence area, the small, the RICs, and the RAPs and XAPs. And so what we did is that we decided to start reviewing the status of O-RAN and 3GPP's work related to AI machine learning, try to identify potential overlaps, conflicts, and also opportunity to align, and then develop action plan and guidelines to ensure such harmonization and unified 6G standards. Now, we started looking at the AI machine learning related workflow in 3GPP. There you can see that there's various versions in RAN 1, RAN 3, and SA5. Largely, they are kind of generic and similar, highlighting the data collection, the model training, and the inference use, even though the different working groups in 3GPP seem to also have a different supplementary element that's built in explicitly or implicitly. But overall, the flow is kind of similar. And in comparison to O-RAN's AI machine learning workflow, actually, the key elements are also kind of very similar, I think, consistent. The only thing that I would say that in AI machine learning workflow in O-RAN, you will see the explicit and very dedicated role of the hierarchical RICs, the near real-time RIC, the non-real-time RIC, and also the associated A1, E2 especially, and of course R1, Y1 as well. Okay. Now, in terms of the major efforts, you will see that in 3GPP, SA, RAN, as well as in OAM area, kind of 3 groups. And then in O-RAN, we have it for the RAN, for OAM also, and also another aspect, cloud codification aspect. That part probably doesn't exist in 3GPP and probably will not either. And specifically, the RAN-related work in 3GPP about AI machine learning, you will see it actually first started in RAN 3 with release 17 study items covering energy saving, load balancing, and mobility optimization. And then the work item or the normative work started following those in release 18. But a lot of the work somehow centered around the existing XN interfaces there. And there are some more extensions cases in release 19. And then after RAN 3, RAN 1 in release 18 started doing some study items on the basically on the physical layer in the air interface for the CSI feedback, the beam management, and the locationing. And then corresponding work items started in release 19. And then in RAN 2, yet another release later, and they started the study item mobility enhancement using AI machine learning in release 19. And also, they are specifically highlighting the UE's role, the terminal's role, and in terms of the AI machine learning model lifecycle management procedure. Sorry, what's the next page? How come I can't move down? Ashutosh, did you do something to the screen? I cannot move. Hello? Oh, okay, I did.
Yeah,
okay.
Jillian, you may want to wrap it up in next 3 minutes or so. We have a
3 minutes.
very packed program. Yeah.
Okay, thank you.
Thank you, appreciate it. Hope you feel better. Yeah.
Yeah, in terms of the related work in SA5 is also very important because SA5, following the core networks and WDAF and WDA, now they have an MDA or MDAF, and where they are providing analytics on coverage, on energy, on resources, and also MDA-assisted management services in terms of fault management and mobility management. And then there is also the management of AI/ML function itself, right? Enabling, I think, network for AI. So the configuration, validation, deployment, and performance, etc. Now, in O-RAN side, I'm just highlighting some use cases, including V2X, UAV, and industrial IoT, and also technology-wise, specifically QoE, experimentation, and massive MIMO optimization, and also RAN slice assurance. All of this, you will see that non-real-time rig and near-real-time rig are paired together with primarily training done in non-real-time rig and then inference done in near-real-time rig. But there's exceptions too, because in some of these cases, you'll see that inference can be done also in non-real-time rig, and then training may be done also in near-real-time rig as well. But I think the important message is that we have about 26 use cases developed in O-RAN so far as focus, and out of the 26, I think majority, which is 16 out of 26 use cases, are really rig-enabled, AI machine learning-enabled use cases. I'm not going to spend time on this. This is one particular example of the work item, the AI/ML for RAN work item, where it identify and specify the workflow for AI machine learning related function services. There are some good examples that I'm showing here, but specifically the enhancement on the key interfaces of A1, O1, O2 coming out of SMO are the focus, and it provides various configurations and scenarios, including separate training interference inference, such as the figures here. One showing training in non-real-time rig and then inference in near real-time. The other actually showing some of the training, the offline training is in non-real-time rig, part of SMO, whereas near real-time rig can be participating in the online training in addition to the inference as well. But then in addition to these two, there is also federated learning that could be deployed, making use of the relationship with a more centralized non-real-time rig and less centralized near real-time rig as well. Okay, in terms of scope I think the summary, I'll very quickly go through a few key summary observations here. First of all, in 3GPP, there is an NWDEF in the core network. We don't have that in ORAN. In the ORM domain, there is the MDEF in SA5. And then in ORAN, there is SMO, non-real RIC, and also key interfaces of O1, A1 involved in related domain. But there is a lot of leverage already across, and even though there are some differences and also some additional capabilities that the non-real RIC is providing through A1, such as the policy guidance and the enrichment information, etc. And on the specific on the RAN, inside the RAN, in terms of this work involving its role in the overall AI machine learning functionality and services, whereas in ORAN, there is the near real-time RIC, which doesn't exist, and along with its associated key interfaces. Well, OCloud, I'm gonna skip for now. Okay, the next one that I want to highlight is specific uniqueness and the similarity between the two organizations in terms of AI machine learning. In the workflow, you will see that actually generically the framework are all very similar, the key elements are the same, but there is a unique instance of hierarchical RICs in ORAN which doesn't exist in BP. The use cases I already mentioned, there's actually, you can see a matching of the RAN3 or SA5 AI machine learning related cases that matches to the related work in ORAN in terms of ORAN goes 3 or 2 or 6, and some cases 1. But there are some uniqueness here, which I mentioned, 16 out of 26 use cases, which I think we have a much larger number of use cases, and also 16 of them have AI machine learning case element. And in terms of data collection, I think similarity is that actually, as much as possible, ORAN, trying to maintain consistency with 3GPP, whatever is existing in terms of the data models related over the interface of XN, EY, F1, if it could be reused, ORAN is trying to be totally consistent and then just building some extension on it, particularly the ones over O1 and E2. And then, but on the ORAN side, because of the explicit presence of hierarchical RICs, we are enabling finer grained data collection, such as near real time and also per UE type of data over E2.
Julian, you have a minute. You have a minute.
Okay, I'm gonna jump to the conclusion.
Try your best to finish up. Yeah, please.
Summary. The gap analysis summary is that the uniqueness of 3GPP that doesn't exist in ORAN, including NWDEF, including UE's role, including air interface, employing air machine learning, channel state, the bin management position, etc. And the uniques on ORAN side primarily is the SMO and the hierarchical RICs, and also the related key interfaces I'm listing here, and also RF XApps. And then in terms of use case, there's a lot of commonality in the existing use case in 3GPP from ORAN, but there's slightly complementary focus, different focus, but ORAN definitely offer many more use cases, okay? So that's the last page. Way forward. Globally unified standards, absolutely must have, okay? But we want to make sure that the standards enables faster innovation, lower costs, and higher performance and reliability. And to this end, I think we do want to call for collaboration, cooperation across all the players in our ecosystem, and actually even across multiple SDOs and industrial organizations, because 6G is a major, the most important endeavor, not only because its scope will not be less than the immense scope that 5G already opened up to us, but also based on the experience and learning from 5G, I think we'll have to do a lot more things much more efficiently, correctly, coherently, jointly. Okay, and so we need an inclusive approach for all the people to bring their expertise, their strengths, their know-hows, and their accomplishment together. So, and the ORAN Alliance, of course, standing ready and willing to work with everyone to achieve this goal.
Thank you,
Okay.
Chilin. Let's give a big round of applause for Dr. Chilin Yi. And
you.
Chilin, please come next time in person. It'll be really great to listen to
Yes.
you.
Yeah, but I'll try my utmost.
And,
I really would like to be able to discuss with everybody there if it's in person.
yeah.
Okay, so I'm going to stop here.
Yeah, so thank you, Chilin. I think that was excellent presentation, keynote presentation, I should say.